A demonstration of our big data analytics project. The project we are doing is human activity monitoring and prediction. So the motivation of the project is that with the aging society, people would have interest in knowing their daily activity uh, levels and would like to predict their um, and monitoring their activity level. So we are using a smartphone to collect the sensor data, which is a practical, small, and unobtrusive platform. So during the experiment, each person performs 6 activities: walking, walking upstairs, walking downstairs, sitting, standing, and lying. And we try to do feature selection and then classify the data into the 6 categories. So the overview of the project is that first we collect the sensor data from smartphone, and then we do data conversion, divide the data into training set and test set, and then we do some time domain and frequency domain feature extraction. In the end, we do classification, and finally we evaluate our results. So the data is collected from a group of 30 volunteers within an age bracket of 19 to 48 years. Um, each person performs 6 activities wearing a smartphone Samsung Galaxy S2 on their wrist. And because of the built-in three-axis linear accelerator, the gyroscope and the accelerometer, we can get 3-axis linear acceleration and 3-axis angular velocity data, and the data was sampled at a constant rate of 50 Hz. So for the pre-processing part, we have to do pre-processing because the raw data needs to be pre-processed in order to be used. The sensor data will pre-processed by applying noise filter and then sampled in fixed with slicing windows of 2.56 seconds and 50% overlap. And the sensor acceleration signal has gravity was separated using a Butterworth low-pass filter into body acceleration and gravity. For each window, a vector features was obtained by calculating variables from the time and frequency domain. And we separate the data into training set and test set with a ratio of about 70% to 30%. And all the different classes have about the same training set and data set number. We extract 1,561 features from the raw data corresponding to the 17 features above, and all the features are normalized within the -1 and 1 range. So we try to classify the data using Mahout. First, the random forest algorithm. We first upload the dataset into HDFS in Hadoop, and then we generate a file descriptor, and then we build a random forest using training dataset. Finally, we use a random forest data algorithm to classify the testing dataset. The result is pretty good. We get 79% accuracy. And then we also try support vector machine and KNN algorithm using Python by playing around with the parameters. We use the best parameter and training dataset to train the model and calculate the prediction accuracy. The result of SVM was 96%, and then result of KN best result is 90%. So based on the comparison, SVM has the highest accuracy. Therefore, it was chosen as the model to build the application. So we also built a UI of real-time activity monitor to demonstrate the project. As you can see here, there are users, and then they have different status and their classification result. For a single user, over time they are classified into walking upstairs, and standing in this example. So That's our demonstration.
Hello everyone. Today I will introduce our method about how to use Mahout to do classification job by implementing random forest algorithm. There are three steps to achieve it. The first one is generate a file descriptor for the dataset, and then we will run the examples with trained data and build the decision forest model. Finally, we use this decision forest model to classify test data and get results. In, Firstly, I will describe our dataset. The trained data has about uh, 7,300 records, and the test data has about 3,000 records. And each list has about 561 features and its ID. And then I will give you the examples about our dataset. Here you can see that the first 561 dataset indicates the state of the actions, and the last one indicates the people is just standing at this time. And our working environment is Hadoop, one and the Mahout. You can see it. Firstly, we should upload our dataset into HDFS. You can see the command here. Firstly, you should just make a directory named user and big data. Here, the big data is the name of your computers, and you can see it in the localhost. You can see the user, big data, and we upload our test and train dataset into HDFS in this path. Secondly, we should generate a file descriptor for the dataset. The commands are given below. When you finish a job, you will be informed that the dataset description has been stored by Hadoop. Then we can build our forest tree use training dataset and using the descriptor we have done before. You can see when you type the command and the job is running, and the Hadoop is just do map and reduce, and finally when the work has been done, you will be informed that the forest has been stored in this path. Just here. And finally, we can use this forest tree to classify testing dataset. You can see this is the command. When the job has finished, you can see the results, and the accuracy of our classification is about 92%. So, so that's all about how to use Mahout by implementing a random forest algorithm, and hope it is helpful for you. Thank you very much.